Hello, I'm Lucy Gray. Welcome to the programme. We start with a historic mission to the moon and the launch of India's Chandhrayaan 3 spacecraft. This is the moment that it took off just under an hour ago. It entered Earth's orbit shortly after. It's India's second attempt at a lunar landing, and if it's successful, the craft will deploy a rover near the moon's south pole next month, and India will become only the fourth country behind the US, the former Soviet Union and China to manage a controlled lunar landing. A little earlier, I spoke to astronomer and podcast host Jennifer Millard, who talked us through the launch of the rocket and explained how long it would take before it reaches the moon.
Once it's there, it'll orbit the moon a few times before attempting to deploy the lander and then the rover, which is contained within the lander. So yeah, we've got a little bit to wait. We're expecting it to get to the moon 23rd, 24th of August. That's the rough timeline. And then, yeah, hopefully India will become only the fourth nation to have a successful soft landing on the surface of the moon, which is absolutely incredible if you think about it. It's only the US, Russia and China that have achieved this. And yeah, India are going for it. You know, they haven't done too much in terms of space exploration. So this is a really ambitious mission, but that's what they tend to do. You know, they were the first Asian nation to reach Mars as well. They've got an orbiter around the moon now that's been operating for over 3 years very successfully as part of Chandhrayaan 2. So yeah, expect great things from India and space in the future. So it was actually the Chandhrayaan program that discovered water at the south pole of the moon and concretely discovered water on the moon. That was the first time that had ever been done. That was back in 2008. And then, of course, they're really making amazing progress, spending very little money on these projects. You know, when we look at NASA's, the budgets run into hundreds of millions, billions of dollars, whereas the Chandhrayaan ones are doing it for $75 million, something like that. We spend more on making movies, and yet India are going to explore.
How are they able to do that so much more cheaply?
So again, it's doing things like taking their time, so using the least amount of fuel possible. That cuts down on the budget, using smaller craft. So this rover, you know, is not the sort of size of a car that you would expect with the Martian rovers. This one is on its biggest dimension. It's about 1 meter long. And so then that reduces the cost as well. You know, lower mass as well is always cheaper. And it's very, very specific targets. You know, we only expect this rover to be working for 1 lunar day. That's one of the things with the timing of this mission as well, is to get there for the start of a lunar day. So we've got that full 2 weeks to make the most of all of that solar power to charge the batteries. And so it means that India can do these extraordinary missions and extraordinary science on a very, very low budget, and does show that you don't need to spend all of this money necessarily to do amazing exploration in space.
Jennifer Millard there. Well, let's speak now to Prasad Subramanian, who is a professor of at Indian Institute of Science, Education and Research. Thank you very much for joining us. I'm assuming that you watched the launch and are following its progress. What can you tell us? What's your assessment of how things are going?
Things are going very well. Fingers crossed, but I believe we've passed the most crucial stage of the launch. And so as of now, things couldn't be going better.
So just to explain what's happened, there was blast off and then the boosters separated from the rocket, didn't they? Those boosters have now fallen into the ocean, and I understand it has now entered Earth's orbit. And then just if you could just explain what's happening, because it's going to orbit the Earth several times, isn't it, before it does this sort of slingshot movement and tries to get into the lunar orbit.
That's right, exactly. It's a matter of entering the moon's primarily the moon's gravitational pull, and it's a complex maneuver. And to be clear, the rover per se is going to land on the moon only in about 2 weeks or something like that from now.
23rd or 24th of August, they've said. Yeah,
that's right. Yes, something like that. So in between now and then, it's a lot of fairly complicated orbital dynamics that's going to happen.
Basically trying to build up speed, though, I understand.
Yes. The slingshot's a very good analogy. You need to get your stone right in the right trajectory. So that's pretty much what it is. But
And
easily put. But,
the easy part, well, the really difficult part, apparently, is landing on the moon. And I know that India tried it once before and it didn't go so well. So talk us through why this is so tricky, what it involves.
Oh, to the extent I understand, it's a matter of think of trying to land on your feet while jumping the top of a building. You need to make sure your feet are strong. I wouldn't recommend this to anybody, but if you were trying to do that, you need to make sure your feet don't buckle, and there's a lot of rebound, and you're not very sure about the composition of the soil where you're landing. So all these things. So that's why it's a combination of mechanics and mostly mechanics.
So Sorry,
Sorry.
I was just going to ask if you could explain what the mission is. As I said, the aim is to land on the South Pole. And we don't know a huge amount, do we, about the actual South Pole?
That's right. That's precisely why we're trying to go there. And the mission, the scientific objectives are manifold. Broadly put, lunar geochemistry and of course, presence of water ice, which is the Holy Grail, and understanding how the lunar surface came to be what it is now, understanding the impact of the solar wind, something that I'm personally interested in, how the solar wind particles impact the moon's atmosphere, or the lack of it, and how they influence the geochemistry of the lunar surface. This is about as much as I broadly understand. Yeah.
Yeah. Well, so far so good. So we will see, I suppose, won't we, in the